Section 8.7 is all about the area and circumference of circles. So area is what fills and circumference is what goes around the circle, kind of like perimeter, and we'll write this down over here. Since we're here, we might as well put circumference is the distance around the circle. So it's like perimeter in polygons. Okay, so what is a circle? You will see a picture of a circle over here, and the circle has a center. So a circle is just a set of points that are equidistant from the center. And so we will write it as circle R. If there was an R here, we could name it. And to show that it's equidistant, we could draw in a radius. And if I draw in a radius there, or I draw in a radius here, it does not matter. They're all congruent. So the radius is just the distance from the center of a circle to the outside of the circle. Okay, so if the radius goes halfway across the circle from the center to the outside, if you draw in a segment that goes the entire distance across the circle, that is called a diameter. And no matter how many diameters you draw, those are also going to be the same length. So the diameter is just the distance all the way across the circle through. Okay, and then we're going to talk about a central angle. Any angle that is here at the center, so it has a vertex that is the center of the circle, that is called a central angle. And if you have kind of a piece of the pie or a piece of the pizza, this is called a sector of the circle. So the central angle is just the actual angle itself, okay? And so if we put like A and B here, an example of a central angle would be angle ARB. The sector would be the entire shaded piece, like a piece of pizza or a piece of pie. Okay, so let's go ahead and look at some formulas. So we have a formula for the circumference of the circle, and if you notice this first diagram, we are given the radius, so it is 2 pi r. Now in the second circle we have a diameter. Remember that the diameter is just a radius and a radius. It's 2 radii, which takes care of this and this. So you could also say that circumference is just pi times diameter. Both of these formulas will give you the exact same answer. Okay, so find the circumference of the circle. We are given the radius, so I'm going to say circumference is 2 pi r. So 2 times pi times 4, because that's the radius, so 8 pi. Now, circumference is like perimeter, so it's just going to be inches. It's not going to be inches squared. That's when you have area. Okay, this is the exact circumference. But if you want to type that into your calculator, you could do 8 pi, or 8 times 3.14, and get a decimal approximation and say that C, or circumference, is approximately 25.1 inches. Okay, the area of a circle is pi r squared, and you can remember that because the units for area is squared, so the radius is squared for area, and there's only one formula for that. So find the exact area of the circle to the nearest square inch. Okay, so here we are given the diameter, so we need to cut that in half for the radius, so the radius is 8. So area equals pi r squared, and keeping with my pattern of writing the formula out first, that will help. So pi times 8 squared. We want to square that 8 first before we multiply by pi, so 8 squared is just 8 times 8, or 64 pi. Now, area is units squared, so we're going to say inches squared. So the area of this circle is 64 pi inches squared. This is exact area. That is not rounded, it's not estimated, okay? But they said to the nearest square inch. So let's go ahead and type in our calculator 64 pi, or 64 times 3.14, and the area is approximately equal to 201 square inches, or inches squared. All right. Example number 3 says find the radius and the diameter of the circle. Notice that we are given the area. We are finding the radius and the diameter, so we are going to work backwards, okay? Because we're talking about area, our given area, we're going to start with area equals pi r squared. And we're going to plug in what we know. We know that the area is 380 pi times radius squared. We don't know the radius, so we're going to solve for that. Okay, remember that pi is just 3.14, so you can divide by pi, or you can divide by 3.14. So if we do that, we get 121 approximately. Okay, because our pi's cancel out, we have 121 equals r squared. So all we did was divide both sides by pi, or 3.14, and we got approximately 121. That's not the radius, that's radius squared. So how do you get rid of a square? You square root both sides, and the square root of 121 is 11. The square root of r squared, those cancel, and you just have r. So the radius is 11 feet. So the diameter then is double that, so 22 feet. Notice those are not feet squared because it's not area. They gave you the area. Okay, you are responsible for 3 checkpoints.